Not an architect. I had the honor to have a dissertation in architecture, but I'm an engineer. So, dear architects, I bow against you. Yeah. Ladies and gentlemen, it's my pleasure to start the session of sustainable buildings and decarbonizing the built environment. And I'd like to share some thoughts and positions and facts about the chances we have to, by 100%, change our heating and cooling system to renewable, what is in fact necessary, absolutely necessary. I will talk about some challenges and many pathways we have as options. The challenge is easy and it's big. The challenge is nothing less than to shape a future of mankind free from natural gas, oil and coal, and free does mean free. So it means leave the remaining fossil fuels untouched or even get them back into the biomass or into the soil in the sea is what is happening nowadays. And the challenge is to get this transition done within the next 20 years without an option to fail. And it's somehow pathetic, but it's true that you are the first generations that really undoubtedly experience heavily the anthropogenic climate change. And already we are the last generations that will have the chance to stop it, so to change it. And I like very much the Smart City Vienna frame strategy head poster. It's about people, it's about young people, it's about nature. So it's not too much about numbers, it's about people. When we look at the built environment, the good message is it's quite easy to decarbonize the built environment. Heating and cooling a building is nothing like melting steel. It's an effort with low energy density needs, and it's an effort with low temperature needs. So these are good circumstances to decarbonize. If we look at the needs of a building stock, well renovated or a building stock newly built, then you can see the numbers of energy demand at this picture. The energy demand for space heating and cooling is already quite on the same level. The energy demand for space cooling is catching up. It's traditionally, we have not been a climate where it was necessary to cool a building. Now the cooling need is really catching up quickly because of climate change. And we are well good beraten. So we are doing a good thing if we tackle the need for cooling in a climate neutral way and do not cause another energy demand out of it. Never forget the energy demand of traffic. It's very much linked to the building, to the way we build, to the place we build. So the energy demand of cars is way higher than the energy demand for buildings, and it's linked to buildings. So never forget about this, and never forget about the household electricity. If you're lucky and have a district heating system in a town like Vienna, 1/3 of the people are in that lucky position, then take it. They will decarbonize. They are working on it. If you're not lucky having a district heating connection, then the good message is there are always solutions for decarbonized covering the demands. One classic solution is for sure the heat pump systems, airborne, ground-borne, and in the Klimaloop system, use the excess heat from space cooling and make it accessible for heating via borehole heat exchangers, for example. My colleague Peter Schöffmann mentioned them in the Plus Energy District lecture minutes ago. I'd like to share with you the outcomes of a study we did. It was contracted by the municipality of Vienna, by the energy planning department. It was a feasibility study where we have asked ourselves the question if in real buildings, in the real building stock, do we find feasible and technically feasible and economically feasible solutions to decarbonize from gas boilers to either heat pumps, district heating or biomass. And we took the building stock as it is, houses of 200 years, of 100 years, of 40 years of age, and looked there if we find the solutions. And the challenge is big. There are already close to 500,000, something between 400,000 and 500,000 of gas boilers running, operating in Viennese houses. To get rid of them in 20 years means to get rid of 55 of them every day, including Sundays and Saturdays and New Year days. So the challenge is big. We looked at 3 starting situations, from left to right: the central boilers, the decentral boilers, and the decentral oven systems. In number, the biggest group is the middle one, the decentral boilers, delivering heating and domestic hot water, and for sure fossil-driven, gas-driven. So I'd like to focus on getting rid of them. First chance, I said, if you're lucky, then the district heating is available. Still, the measure will be to connect to the district heating system, to install a district heating station, a central one, to install uptakes and find a solution for the domestic hot water stations, either a station or a small boiler or something like this comparable. We did calculations based on estimations of colleagues, based on designs of our own office, based on statistics, and came up with average numbers being valid for a house of 20 flats, 1,400 square meters. This is our baseline building. And the numbers are before tax, so without added value tax. District heating, if there are no special challenges, you will get it for 6,000 euros per flat. There are special challenges, like for example, district heating is there, but it's far away. Every 20 meters will cost another close to 1,000 euros per flat, but it's possible. It's just digging. If there's no district heating available, there's still the option in most cases to go for biomass. Biomass is not the first option in a city because there's fine dust and emission aspects, but it's available. If we change a decentral gas system to biomass, again, we need a central boiler, we need a pellet storage, we need uptakes, and we need money. It will cost more than the district heating system. Usually, we estimated it at a cost per flat of 7,000 euro. But possible, technology available. It's no rocket technology. It's well-proven, robust technology, which is on the market since 20 years. If there's no biomass available or no biomass option wanted, then we have the 2 groups of heat pump options. We have the airborne heat pump and we have the ground-borne heat pump. I focus on the airborne heat pump in this case. Again, we have a central air-water heat pump necessary to be installed. We have outside heat exchangers, or put the heat pump already outside. Again, the uptakes needed, again, the domestic hot water station. And the big question is coming up with these systems if the old radiators will do their job, or if the temperature level of the old radiators is not adaptable enough to the new system, or if the new system is not adaptable enough to the old radiators. If nothing happens in the worst case scenario, then we will get along with something like 11,000 euros. Again, technology is available. We hate the outside units. On the left-hand side, you see those heat exchangers, which are always ugly to look at and which tend to be loud and noisy, so we do not love them. I agree. The other components are okay. The heat pump in the cellar, the heating domestic hot water stations in the areas. So if there is a problem with noise, I start with a problem with the heaters. There could be a problem with the heaters. The old heaters could be of a too high temperature level and they could have to be replaced. Yes, that's an effort, that's nasty for the building who lived there, but it's doable. And it will cost something like 2,500 euros. They have to be low temperature radiators or heat pump convectors. They will do the job. There can be a challenge too. The challenge too can be noise aspects. When you have an area where noise aspects, neighborhood aspects are important and tricky, you could have been forced to add another heat exchanger outside to get the noise down. Another costs necessary. but solutions available, either multiplying the numbers of components or doing noise protective housing. If there's no space left, you can be forced to move to the rooftop, to put the outside stuff on the rooftops. That's no rocket technology either. It's costly, another 3,000 euros in average. Is it easy to do this? Well, not in fact easy, but possible. I bring you some images. You can say this is ugly to look at. I say it's no less ugly than chimneys has been. And I like heat exchangers for heat pumps much more than I do like chimneys. Yes, there's a chance in it. If you go for heat pumps, you have the chance of summerly heat protection included, so cooling included for some other 1,000 euros, but cooling, climate neutral cooling included. I come to an end. You will find the study in the internet at the page of the MA20 Energieplanung. It's available there in their study collection, and you will find their concepts, plannings, and a list like this about average costs. Yes, the good message is the technology is available at fair costs, and the good message is it's already used, not in a pilot status, but really in the real world and in the real scale. Failure would be ways more expensive. Failure would be deadly. I'm very much convinced of that. And to cite our Ministry for Environmental Affairs, failure is no option. So good luck in your own efforts to fight climate change and work for a good future of us all. Thank you for listening. Many thanks.